Greetings, everybody. I think we are recording and awaiting Tangent's presence. I know that our homework was to model the camera lens system that we use in our rigs. I've thrown a curveball into the works to ask Larry a question that may be of interest to some other people who may be stuck on the same problem concerning joints and copying components with joints functioning.
I didn't know, Alan, if I did a scan just of the camera body, and it didn't give much depth of field, which I know it's what we're all about, of course, but you know, but bear in mind what we're after here is, you know, just a scan, isn't it? So I wondered if I'm missing something on that. Well,
that's going to be exactly what Larry explains to us, the various different ways that we can extract that information from a photograph or a scan. I be honest, I have not. Hang on. Larry is okay. He'll be in shortly. He's on his way. Yes, there are various different ways that you can get the information, either by drawing it, measuring it and drawing it, or by photographing it and importing it. And I'm hoping Larry's going to explain all of the finer points of that. While we're waiting on him, I'll show you the conundrum that I'm in right now. Maybe somebody with a bit more 360 experience can help me figure this out. But while we're waiting on Larry, I'm going to share my screen for a second. This is the latest iteration of the 3D polarizing. Cross-polarizing platform that I built. I made many of these things now, but this is the one that I think I'm going to go with. This is one level of 4. There's also a lighting level below this and a cap on top, but this is the important part. It's what did I call this? The drawer. It's got a shell or a base and a drawer, and then a cassette that goes on the inside, and all of the parts are different colors so that you can see where the different components are. This piece swings out with supposedly with the cassette attached, so that you can drop in your different polarizing films or your subject, and each of the cassettes is different, but the structure is otherwise the same. When you drop this back in, you close this. This is a joint right here, and there is a window in the side of this piece, though you can't see it because for some reason it didn't transmit over, but there's a window that your fingertip can be used to rotate the cassette. Now I've made a couple of these in different ways, and they all got so messed up trying to copy this and make new layers that could be edited independently, and that's what I'm asking Larry about today. Though if it's not part of what he wants to talk about, we'll do this offline. But I'm trying to figure out how to make copies of this that are independent. There's an instruction that you can give it, which is paste as new, but it doesn't show up when I copy the level. It doesn't show up as an option to paste it. So that's one of the things I want to pick Larry's brain on. I will actually show you the version before this, because that might show more what it's supposed to look like in the end. Hang on. If anybody sees Larry come in, just yell and I'll stop talking. Now, what was it called? The cross polarizer. See, I've got quite a few of them. I think I called it the XPL. No, this was the one. Nope. Oh well. If you don't remember what you called the thing, it's hard to find it. Well, I kept changing the name because I ran out of things to call it because I have so many of them. Oh, I'll look at the date. Good idea. There it is. Oh no, that's the one I'm working on now. I'm very good at this, aren't I? It's 7/16, nope. Wrong year. Can't believe I've been doing this more than a year. VHO. There. So this is what, with all the components, different colors, this is what the stack would look like with all the 4 drawers, 4 chassis, and 4 cassettes. But while I could get all of these like this, I couldn't operate the joints independently, and I couldn't edit the cassettes independently. I edit one and it edits all of them. So that's what I wanted to bring up if we get a chance today. But just as an update, that's where I am. This looks more complicated than it is, but
Alan.
oh, okay, great. Then I'll stop talking. But after I say this, the thing sits like an alarm clock on these two cylinders, and then it has 4 little handles for each of the doors. Larry, I was just filling time, showing folks what I'm messed up with right now, and I'll turn it over to you, Mr. Tangent.
Can you email me that file?
Yeah, I just messaged it to you, but I'll email it.
Yeah, I'm not able to download it.
Okay, this is not the one that I sent you. The one I sent you is the one I'm actually working on now, which is, I simplified it to just one level so that it wouldn't be as confusing. And I'll show it to you, then I'll send it to you.
Okay.
It's, hang on. There's probably a way you can list these in order, isn't there? Or is this the one I'm showing now? No, that's the one I've got now. It's, there it is. This is the one that I'm currently working on. It's just one level. And the problem is, how do you copy it with the working joint so that you can edit it? And all three components are the device so far. I will email this to you, and I will stop sharing and turn it over to your good hands, sir.
Okay. Sorry, I had a bit of a it was our park picnic today, so I had to get my lunch, and it took a little longer than I planned.
Well, if you need more time to eat, we can.
No, I got it.
I thought there was an interesting bird out on the deck.
Yeah,
That's what he was eating.
The blue heron. I wouldn't eat one of those things.
No.
Tell you what, if you watch one of them spear a fish, it'll give you a lot of respect. They move fast.
They do.
Yeah. Way faster than you think.
Oh, for crying out loud. Anybody got any burning questions?
Just the two I sent you.
Oh man. Just a second here and I'll get it.
All right. Emailed it to you, Larry.
Okay.
I feel a bit guilty, Larry. The dog ate my homework. I'm sorry.
That's all right. It was more about, I mean, the main focus of that was to get you into you can use this stuff for more than 3D printing, right? You're not going to 3D print your rig. But it's nice to have the components when you, like when you build a rig, to have the components in there so you can move things around. And why can't I get that to work?
It gives you the ability to have visual as to whether what you're trying to design really will fit.
Right. Exactly. Exactly. Instead of building a bunch of stuff and then figuring out it can't. Does anybody know how to turn on the preview, windowed preview in OBS?
Yeah. Preview mode. On the right side where it says studio mode, if you click on that, it'll change the mode to add the preview. Under the controls window.
Ooh, man.
Did that do it?
No. I think that's specific to streaming.
Could be under settings. If you go to
Output?
recording audio. Yeah, output mode. You're right. Under output mode. No, forget I said that.
I've done it before.
Yeah, so have I.
You guys are sounding like me. I've done it before.
It's a
Yeah, there's then been an update.
Oh, here we go. Jeez, oh Pete. So you right click on the view. Jeez. All right. Now I gotta go to Zoom. Where'd that go? See, what my problem was I didn't get the half hour to reset everything from the live stream, and I have about a gazillion windows open from that.
me too.
I resolved that issue. I only have one screen.
I have 3. I really can't work without 3. All right, how's that? Do you see Lightroom?
Yes. Windowed projector in preview. It's pretty fuzzy.
Is it?
Yeah, pretty low.
Does that help?
Yep, that helped a lot.
Now I got to figure out why you can see Lightroom.
It's actually not Lightroom. It's showing fast raw viewer. that an add-on, Lightroom add-on?
Hang on a second. No, that's a different app. I was going to show that when I talked about my,
Are you in
there we
OBS?
go. There we go. There we go. Jeez, oh, Pete's, man. Has anybody used Fast Draw Viewer?
I have not.
It's a little $30 program.
That's why I haven't used it.
The reason I use it is because it's a fast file viewer, but you can do this thing here where can you see the green highlighting in here?
No.
It went dark.
Right. And there's little green highlights, like almost like focus peaking. And you can go
Oh, I see it
through.
now. Yeah, yeah.
Now I see it. Yeah.
And that's how fast it is, even with a raw file. So if I'm wanting to do a stack that's only part of an image, I can use this to find my stacking zone and decide which images to stack.
Huh.
You can do other cool stuff with it, but it's kind of my main culling app.
What's it called?
Fast Raw Viewer. All right, let's get Fusion up. So, geez. We're on a Mac today, Larry. Come on. I was hitting the Windows key and nothing was working. So my plan, since I figured nobody was going to get their homework done with Alan being gone for 2 weeks, um, I was going to do a little lesson on how to draw things from images that you find.
Larry,
Yeah.
could I ask on the homework? I did scan my camera body. My
Okay.
plan was to scan each piece rather than try and support it all in one go.
Right.
When I scanned the camera body, the depth of field wasn't great. You know, you like got the whatever the left hand or right hand side, whichever one
Oh,
was
yeah.
sitting on the glass.
Yeah. Yeah.
Do I have to play a bit more in the scanning settings to get something with depth? Because I take it we need the depth of the image. Yeah?
No, you're just not going to get it with a scanner. Your better bet is to maybe use your phone.
With a LiDAR thing on it?
Well, no, just take a flat image, right? You know how you can have it tell you when you're horizontal?
Yeah, on the levels. Yeah, what you
Yep.
know what I mean? The bubbles.
Right. So you just take a picture. Can you see Fusion now?
Yeah.
Yeah.
Why is it being so slow? Jeez.
You got all those windows open.
Yeah, I mean, I got plenty of memory.
Don't we all?
Well, we
Used to.
talking about up in my head, or we're gonna update. See, there's the problem. Update later.
Well, Larry, is it possible to use a photogrammetry file that comes in 3D? Can you import that into Fusion?
If you can make it into a mesh of some sort. So you can insert vectors, you can insert components, or you can insert meshes, which are STLs, OBJs, or 3MFs.
It's a pain importing
Working with them.
OBJs to
Yeah.
work with.
Yep. Fusion's not really built to be a mesh editor, which is part of why I want to learn Blender.
Yeah.
So for my camera, instead of taking pictures of it, I decided I was just going to do a Google search for images and then insert those. So when you do an insert in Fusion, you have two options for images. One is a decal, which is basically like paint, right? And it's purely cosmetic. And the other is a canvas, which you can calibrate. So I'm going to insert a canvas. And I have them here. I don't remember which one is which. Oh, I can change icons.
Decal is just a zero mass shell, or it's just the outside. It's a hollow.
I'm sorry. What was that?
When you choose decal instead of canvas, is that just the shell that?
It's not even a shell. It's almost like paint.
Okay.
It would cover up a material.
Right.
It's a sticker. I mean, it's a decal. It's a sticker.
Got it.
So I have, maybe I can show you, I should show you the pictures. Documents. So I was able to find, because of all the review sites that are out there, I was able to find these JPEGs of my macro camera. Not the macro camera I would have chosen, but it's mirrorless, and macro with mirrorless is way better than with a DSLR. So, whoops. So the critical, go ahead.
Can I ask your opinion on what you just said?
Yeah. Sure.
What's the difference?
Partially it's because live view is very clunky, at least on my D500. I mean, it sounds like it's going to fall apart every time you take a picture. It goes ka-chunk, ka-chunk, ka-chunk. And it's just not very good. If you have a Canon or some other DSLR, the live view might work better. But live view just lets
You
you
use mirror lockup.
I don't know if you can with live view. Alan might know.
Yeah, the situation for me was, until I had a mirrorless camera, I couldn't understand what all the fuss was about. The mirrored camera worked fine using mirror lockup. You know, it was a little on the clunky side, but it was all I knew, and it seemed perfectly adequate. Within a day of using mirrorless, the fact that you have the electronic shutter, you have no moving parts, no vibration in the camera, and basically no downtime whatsoever. You can shoot as fast as you can shoot, providing your lighting is taken care of. It just is so much faster and so much simpler without having to worry about the motion of the mirror. Now, the quality of the images, it's hard to tell them apart. I mean, they're basically the same sensor between the Z8 and the D850. It's just a matter of convenience and speed for me. And once I used mirrorless in the studio, I can't stand using the D850 to stack with. It does sound like the camera's going to fall apart. That clacking of the mirror that you can hear from the other end of the house makes me wonder how I ever got so many exposures on my D7500. Image quality, not an issue.
Up to it's time saving, and then you're not dealing with mechanics of the camera.
Yeah, so you greatly reduce the issue of vibration caused by the camera. You greatly speed up the process, which is awesome for subjects. A lot of my subjects will droop after a while. I can shoot so much faster now that spasm of the extremities, the stretching out of a grasshopper's legs, all of that stuff becomes beside the point with mirrorless. Where it was a big deal, I had to think about it every shot with the mirrored camera because it was taking 25 minutes to acquire the images, where now it can be done in 4. It is a big difference. Sorry, Larry.
Larry's glad you answered. Are we losing?
Yeah, Larry appears to be frozen. But I love these pictures of his camera. That is,
Yeah.
I would love to find where he got those from. You back, Larry?
Yep, I'm back. Can you
Okay.
hear me?
Yep.
Okay, so I started with this one because everything you reference on your camera and your cage is going to be based on the tripod socket, right? Forgot to hit a button. So the first thing we want to do, you'll see in the tree, we have canvases. I'm going to go ahead and edit the canvas, and I'm just going to, the nice thing about when you're doing I call them volumetric models, you don't have to be exact, right?
Larry,
If you're close.
your map on the top right references this as the top. Is that just because it's the first picture you chose? Can you check? Can that be changed?
So when you put a
Keep-
canvas in, it's see-through. It works on both sides.
Okay, got it.
I chose the top plane. It does flip, so the viewfinder, which is on the bottom here when I'm looking at the top, and if I'm looking at the back, now the viewfinder's on the top or the bottom, the viewfinder's on the top of the screen.
Understood.
So now that I've got it where I want, I could either measure a known object that I can easily click inside this image, or I can simply do some more digging on the internet, and I can see that it's 135 millimeters from the edge of the lug to the edge of the lug, probably. And that's probably going to be close enough. So I right click on the image. Whoops, I moved it, so I gotta click OK. I right click on my canvas. I click calibrate. I'm just gonna eyeball the edge of that strap lug and the edge of that strap lug.
Does the calibration become more accurate with the more data points you enter, or you just stick with one?
No, you just have one measurement. But you can see this is on an angle. So if you have that kind of situation, I'm just gonna hit escape.
It would be logical to have to take the biggest measurements, and then that would mean
Right.
the accuracy of the other ones would be better.
Correct. Very good point, Graham. So I'm gonna let's see. we're going to calibrate, and I'm going to pick this again. I'm going to pick right on the line, and then again, this is a volumetric, right? I'm really not trying to make this perfect. It's more about speed. And it's 135 millimeters. I just put in the number of the actual dimension. And now I'm going to insert another one. And let's do so what is important here is that you have your plane of where you want to sketch be roughly where you want it to be. So before I insert this next canvas, I'm gonna go into my top view. I could go into, it doesn't really matter where the view is, but I'm going to construct an offset plane. And I'm going to put it right to there. Go back to my isometric view. And I'm
What
going
is the
to,
purpose of the offset plane?
that's where I'm going to put my next canvas, which is going to be the front of the camera.
Why would you not just use the same origin point?
Because I'm going to want to extrude one of these sketches.
Okay.
And I could extrude it two directions, I guess. 6 of one, half dozen of the other.
Okay.
Um,
So do you want a separate image for every face or surface that has a unique feature on it?
I'm just gonna do 2 for this one, but
Okay.
Every feature that you would want to model, yes. I'm really just gonna go for a cube, you know, a rectangular cuboid or
Just
whatever.
a shape, yeah.
Yeah. But I'm gonna make sure that I have the lens as good as I can and the tripod socket. Those are the key dimensions, right?
Okay.
So I need to edit this one. I can rename this, which is always a good idea to rename things. And again, I'm just gonna this one's kind of tricky because you gotta adjust your view until the plane disappears. And then you can slide it up there.
There's no sort of referencing that first image, Larry, and then
No,
being able to punt any numbers in, is there?
nope, there's not.
Okay, that's right. I've just
Yeah. And it's just it's kind of a fiddly thing, but once you get it done, it's kind of nice. So,
yeah.
so we can do that same, calibrate now from here
Is it important that
to
you
here.
use the same
No,
dimension?
I could have, if I knew that, you know, if I measured the outside diameter of the lens mount, I could have used that. I'm just doing that because I have the number up on my other screen. So I put in 135. And now I probably, or I may anyways, have to, oh, actually looks like it lines up pretty good.
I was going to say that looks close.
Yeah. Thank you, whoever took those photos. That's pretty amazing. So then go ahead.
I was going to say they obviously bothered when they took them, didn't they?
Yeah. So, and then it's just a matter of, I'm going to come in and create a new component, and we're going to call this ZFC volume. And I'm naming it with volume so I know not to measure anything off it. Because it's not, you know, completely accurate. And then we're going to create a sketch. And we're going to do that same plane. It's grayed out like that because I did the canvases outside of the component for some reason. Because I forget to create the component. But then it's just a matter of, and you can get as fancy as you want with this.
These are just lines in Sketch.
Yeah. Yep.
You're at.
And again, the idea isn't to be completely accurate. Whoops.
Yeah, because it's not going to print. We're not printing it, are we, Larry? So
Right. Exactly.
ultimately, you just want sort of a length and width to fit the rest what is going to be print round it. Yeah.
Yeah, exactly. And you're even not printing for something, you're not printing something to hold this thing, right? You're not going to build a case for this camera.
Nope.
You just want something that shows the space that it takes up inside your rig. So I'm going to finish that sketch.
It's
What was
just a
that?
placeholder.
I was going to say we're not going to fit the rig to 1,000th of an inch or something, are we? So
Right, exactly. So I'm going to go to front. And, you know, maybe I'm going to get fancy and do the mirror. But that looks complicated to me. So I'm not really gonna do the prism. I'm just gonna do enough to make it look decent. And this is where, you know, if I wanted to model all of those dials, see what happened there? I didn't, for some reason, when I calibrated, my vertical move got off.
is it on the top reference plane of the camera now?
No, what happened was when I scaled it, when I calibrated the canvas, it's like a scaling of the image about the wherever I clicked for the calibration measurement.
Okay.
So that distance was X number of millimeters from the origin, and it referenced that from the origin and scaled it, right? So pretty easy. I can just edit the canvas, eyeball it again.
Why would you not use the optical axis as your key feature for calibrating?
Well, I have two features for calibrating. Well, okay, the optical axis wouldn't be a calibration, but I definitely want my optical axis to be relatively accurate. Again, we don't need it, millimeter accuracy.
Right.
So we want the reference points to be where you're going to mount things. So you're going to mount things at the tripod socket, you're going to mount it to a plate, and you want the lens, the circle of that lens mount.
Right.
So you can model a lens.
Got it.
So I'm going to press pull this to get it where I want it. I'm just going to go up to there. And this is where you got to be a little careful. See what's going on here? The whole, my viewfinder and my bottom is in this area, right? And my lens mount is up here. But this it's asymmetric, right? It's not centered.
It looks like the body's backwards.
Yeah,
Isn't
exactly.
the isn't the bit on the right where your left hand goes?
No, this is the right side looking at the viewfinder.
Oh, okay. All right. Okay. Then I am backwards. Okay.
Right. So, um, this is really should be,
No, we're not looking through the back of the front face image, are we? Because the Nikon would read properly if that was the case, wouldn't it?
right.
Larry, when you picked the second plane for the second image, I think you had the wrong plane, didn't you?
I may have. Let me, so we can fix it this way. I'm gonna edit the canvas and I'm gonna horizontally flip it. Now it's correct. No, it's not. Jeez. That's right. Easy to get lost when you're doing this. Um, so what's going on is a canvas. We were looking at it like this, right? Did it say Nikon correctly before? Or was it backwards?
It was backwards before, but it's right now.
It's right now. Yeah.
Yeah.
So I can create a new sketch. And I'm just going to start on the front of this object. Because again, I'm not trying to be perfect with it. Not sure why it was doing that. There's a tip for you. If a tool is acting funny, just get out of the command. Now in this one, I'm gonna we'll go there. It's gonna be close enough for what I want to do. We'll finish the sketch. Extrude it. And we're going to come this way. And I do want to get that it comes out. So now we've got that. And then the trick with approximating circles is to, we're going to create a new sketch on that front face again. I'm going to do a circle, and I'm going to use a 3-point circle. And then whenever you're like digitizing an image, you have to kind of play with how close you're zoomed in, right? If I zoom in too close, it starts getting fuzzy, right? So you're gonna kind of get it right to the spot where you're confident you're selecting on a line. And then make sure you're selecting the same reference circle.
And that's respecting the resolution of the image you've picked up, isn't it, Larry?
Correct. Yeah. And it's totally dependent on that resolution. So that looks pretty good. And you can kind of test. What the heck? Oh. Let's turn our body off. You can check that. Why? Oh, now I can select it. Jeez. I don't understand why I can't offset that.
I think it's because your sketch is on a different plane. Your sketch is on the plane of the back of the prism.
No, my sketch should be. Let's bring the body back on. It's in the right spot.
Yeah, it is. Sorry.
That's all right. So we can do that another way. What I was going to say is you could offset the circle, but for some reason I can't seem to offset the circle.
Could you project that circle up onto wherever you are now?
You could. Boy, it's not snapping or anything. Now I can. So create a circle. Oh, jeez. So instead of doing an offset, I'll just draw another circle and use the center of the circle I already have. And just by rubber banding it like this, I can see whether or not my center is good. Just by eyeballing it, looks like I nailed it, right? See, I can see the edge. And then we can extrude. Turn the body off. Why? My fusion is acting really strange.
Is it because you're pushing it with what we're doing?
I don't think so. I think it's because I have an update that I'm supposed to be installing.
Oh, yeah. So it's sulking.
Maybe. So the other thing I kind of wanted to show was, you know, I have all one body right now. And that may or may not be what I want. You can always go back and edit the feature and change it to new body. Now I've got two bodies. But for the purposes of this drawing, I actually want to
Two bodies,
modify
all
that.
one component.
Right, all one component, but two bodies. I'm going to push pull this in, and I'm going to use, you can see the flange right there. Right about there. Oh, there's something wrong there.
Yep.
That explains it. See that?
It's at an angle.
Sure as heck is. Look at that. How did that happen?
I'll do the tube lens.
But then would you model the different lenses so that you could turn them on and off depending on how you're set up?
Yes, I would. I would put the flange out there so it's about right, but figured out what happened.
You use the front of the thing as a sketch plane and it's not parallel to your axis.
Bonus, you get a gold star. Because it was just a freehand sketch, right?
Yep.
Is it a tilt shift lens?
Yeah, that's what it is. Or a maybe one of those Holgas where the lens flange wasn't necessarily perpendicular to the film plane. So
Create an
how do
offset
I
plane.
correct? Do an offset plane, and I'll just pick a vertex. First I have to select the plane. Actually, I could have used that one. Where is it? Construction.
You want to go to your coordinate planes, not anything off the sketch.
Right. This plane right here, if I turn off the canvases and I turn on the origin, I already have an offset plane where I want it. It's that one I just created. That's why I did it that way, Alan, instead of at the origin, because I knew I'd need it later. Do you believe me?
Yes.
Trying to quietly eat my lunch.
All right.
Isn't video conferencing useful?
All right, let's try this again. Get it right about there. We're going to create a circle. We're going to do a 3-point. Bang, bang,
Will you guys eat some of this if I send some home?
bang.
There you go.
Looks like I can offset it now. Amazing when things are all in a plane. How well they work, huh? Finish sketch. Should have known something was wrong. Oh, new body. It's giving me an error because I turned off all bodies. Let's go to top.
Looks like your sketch plane is. Am I still on?
Looks like that was a little bit off, so not sure why that happened. But close enough for what we want, right? We can now mount this on a plate. We can put it in our cage and we know how big it is. For the lenses, it'd probably be quicker just to measure them, as long as you don't try and put every step that's in there in them. Does that make sense? Oh, there you guys are. So that's the quick and dirty volumetric model. The other nice thing about doing these, when you take off the pressure of getting it perfect, is you get a lot of experience. You just grab something, right? Or a picture of something and just do a model of this level, and you'll get better at working with construction planes. You'll get better at working with constraints. You'll get better at doing sketches.
Is there a way you can save these, Larry, as volumetric components for when you need to use them again?
It'll just be a component. So if I save this as ZFC volumetric, and then I open my cage project, I can just bring it in.
Is the volumetric model also parametric and stored in the same place?
It's a full Fusion 3D drawing. The only difference about it is that it's not precise.
Okay.
Okay, but now I can put it in here and move it around to wherever I want to place it.
Larry,
Yeah.
should you have said it is precise, but not necessarily accurate?
Sure. That makes sense.
Yeah. Okay.
I have been known to get pedantic on those two words at times. I'm sure Jeff has too.
Many times.
So that's the value of that. One, it's a nice low pressure way to practice, and two, it's useful, right? Because now I can design things around this so it doesn't hit it, and I can get a feel for where it's at relative to what I'm doing. And you know, if I have some sort of linkage, am I going to have room to get to my, you know, to my panel on the where my plugs are over here, you know? So you can start visualizing that better instead of designing yourself into a hole where it's like, oh, I built this thing and now I don't have room to plug in my HDMI cable, right? And you could do the same thing for the end of your HDMI cable, the stiff part, right? Not the the whole cable, but the part that won't bend, right? And you build it big enough to have the clearance you need, and you smack it on the end of there. And that way you know where it is. The other thing that I wanted to show you guys today, just real quick, it didn't come up. I was hoping it would happen automatically, but I'm just going to create a new sketch, and it's about what happens when you're sketching. And I was getting it a little bit as I'm just drawing this. You see how these angles are coming up, and if I let it, you see the perpendicular symbol showing up on that line? So what Fusion is doing is it's guessing at what you want, and it is adding those constraints. But what if you didn't want it to be perpendicular? Say, I don't want this one to be perpendicular. You can just come in here and delete it. And now I can move this, and now that's no longer constrained. Okay. The other thing is when you get constraints can be.
Larry, if you
Go
had
ahead.
removed that constraint and there was another dependent constraint, would that have been removed as well?
No, when you delete them, there's only one constraint that gets moved.
So if removing a constraint is prohibited because of another constraint that's already active,
That shouldn't be the case.
because that would be an over-constrained model then.
Right. It wouldn't let you add it unless
Add
you go over it. So the other thing that happens, and when I first started, it was hard to get used to, you know, okay, I should have everything constrained because when I come back and modify it, if it's not constrained, things will break horribly, which you've probably found already if you've modified a drawing that you didn't constrain. You'll get things popping off out of into nowhere. So as you constrain your drawing, your sketch, so I'm going to put in an endpoint to the origin here. Whoops, not what I wanted. Command Z. I want to dimension it. And I'm going to dimension from here to the origin. And we'll call it 550. And you can see that only constrained this vertical line, right? And it's pretty easy to figure out that, well, okay, I should probably throw some dimensions on this. So we'll give this 35. Look at this 40. I'm going to delete this. And maybe fill it in just to give us some things to play with. Oops. It can sometimes be difficult to tell what isn't constrained and how do I fix it to get it constrained. And it's really not as hard as it may seem. And the way you do that,
Right.
what's that?
It's blue, it's not constrained.
Right, but how do you get it constrained? Like I put a dimension on this line, why isn't it constrained?
Because it can move left and right.
Right. Before you get good at seeing that, all you have to do is put your mouse pointer on it and drag it. Okay. You're like, oh, so that's where my degrees of freedom are. Right. And then that tells you, oh, okay. So if I put a, another dimension here, whoops, dimension, and we'll call it 50, still not constrained, but now you can see that those are locked together. See how it changes as you add constraints. What you can get away with moving changes. And that tip probably saved me a ton of time trying to figure out constraints because I was having a hard time. I would either be under constrained or over constrained, right? More over constrained than under typically because I'd just try and constrain everything, right? So it's really handy to figure that out.
When do you add dimensions before constraints, or is it dependent on the model?
It depends on the model. Quite often I'm putting dimensions in first because when I'm drawing something, I'm dimensioning it.
Yeah.
Other folks do not model that way.
I see people just throwing together a rough outline that looks something like it and then going back and adding
Yep.
dimension.
Yep.
That seems
That's
to be an extra step to me.
No, that's the best way,
It
the
is.
fastest way.
Why is that?
Because you start with the shape and then you tell it what the shape is supposed to end up looking like.
so
Right. But
my
why couldn't
thought
you
on
do that in one step?
my thought on that is it depends on where your design is coming from. If you have the numbers, you know the critical dimensions,
Right?
then I think it's quicker to do it as you draw it. If you're conceptually doing something,
Ah,
you know, if you're starting from a more conceptual starting place, then
and you
what Jeff
don't
said, it
really
makes
know the
perfect sense.
relationships.
Right. You just know the shape that you want. Then the nice thing is you can do it either way.
Yeah. And my workflow is to draw it on a piece of quad ruled paper before I open Fusion, so I know what the key dimensions are going to be. And
You will probably find as you get better with Fusion that your detail in your sketch on paper will be less and less.
So,
And you'll
Larry,
yeah.
But then
so if you had your front of your camera, you could do a
Mhm.
sketch. You could do a rough sketch of that, then dimension it to make it accurate. So if you were
Sure.
starting again and just
Yep.
doing the front of it, you could do a rough drawing first, knowing
Yep.
roughly what it looks like, and then dimension it after, which might be quicker than trying to actually dimension it as you draw it.
Yes.
Yeah. Okay.
And you can refine this as needed. Okay. You know, say you wanted to design something to go in the cold shoe that's going to hold a diffuser. Well, how do you know you're going to miss all your buttons? on the top panel.
Mm-hmm.
Well, I'm going to have to model the top panel now. Right. So that volumetric can get more accurate over time. You just got to be a little careful. I probably spent less time than I should have on that base sketch. I should have constrained it so that my horizontal lines were horizontal instead of being almost horizontal. Right. And that kind of stuff. I mean, a lot of it's just doing it. The more you do, the better you'll get once you get past a certain level. If you can create a drawing like that, you probably know enough to keep going and just practice and start trying to, Alan, try to design something without drawing it on paper first as a challenge.
Yeah. It was actually, I think it was you that told me right early on, sketch it
did.
on paper first.
I did.
And
But that's
it does help me organize. I don't like to be halfway through doing a drawing and then have an idea of something that might work and add that on if I didn't think about it up front. But maybe that only works for simple.
well, no, that works for all kinds. I mean, you can't sketch out an overly complicated, something super complex with lots of parts, but you break down those parts into their components, you can. I mean, we don't draw a bridge all at once. When I was drawing bridges, we, you know, we did it an abutment at a time and beams and,
Sure.
pieces, parts.
At what point in your process do you convert dimensions to parameters? And how do you choose what to parameterize and what to leave fixed?
So if you're familiar with CAD, traditional CAD, we had things called blocks or cells, right? And those were things that you reused. And I used the same approach to parameterizing a design. So I wouldn't spend the time to parameterize my ZFC volumetric model or even a detailed model. I'm not going to modify that model, right? I might modify something if I found out I had a bad measurement, right? Where it's worth time doing parameters is this guy.
Like
That's
a
right.
class of products.
Right. That ahead of time, you are going to want one for a tube that's 43 millimeters and one that's, I mean, that was kind of in the initial design proposal for the clamp was we had different diameter tubes. Well, that's a perfect case of do it with parameters because a tubular clamp that you can attach to a 1/4 plate is going to be a ton of different uses for in a ton of different sizes
Right.
and widths and diameters and heights and all of that stuff. You made it into a parameter so that thing can change. You can change the thickness of the pad you're using because you
I'm a
may
little
use, go ahead.
confused by the concept of when do you change a dimension into a parameter? Is a dimension not by definition also a parameter if you're in the parametric modeling
So,
mode? You don't define something to be a parameter, you just give it a dimension, right?
so this is a case of fuzzy terminology. Okay. So parametric modeling means I'm modeling based on parameters, which is kind of loose. And in a way, working in Fusion is parametric modeling because I can draw a cube and then I can later change the dimensions of the cube. And that's in a
Right.
generic parametric design sense. Okay. what we were just talking about, converting dimensions to parameters, are specific. That's a specific terminology for Fusion. In SolidWorks, they're called something else.
Larry,
Yeah.
I would explain it as a parameter in Fusion is analogous to using a variable in mathematics.
Yes.
So rather than having an equation 3 plus 1, it could be n plus 1. So
So when you go into the change parameter screen, when we're
Right.
talking about converting dimensions to parameters, this is what we're talking about.
Okay, but that populates whenever I dimension something. It populates with the user number.
Correct.
What am I doing when I
Well,
change? I
so these are model parameters, and they're based on the commands.
okay.
See, model parameters, ZFC volume, we have the extrude, how far,
Sure.
taper angle, all your
All
settings.
the all the things you told it to do.
And you can edit these,
You
and
can.
it'll change it.
Correct, but
That's
when,
different than here. These are user parameters.
yeah,
Okay, so let
but they're
me
determined by what you said in your dimensions as you were drawing it.
yes.
So there isn't a point at which you say, okay, this dimension is 20 millimeters. I like that. I'm going to now make that a parameter. It's already a parameter.
It's a parameter in the generic sense, but I have not named it as a variable.
Okay.
Is it
So-
Larry? Sorry.
Go ahead.
Isn't it in relation to something else? So if you said, I don't know, something is half the diameter of something else, that's a user parameter, isn't it? You make one dimension relative to something else. Is that right?
Not necessarily.
so
Okay.
you can put a formula into a user defined parameter rather than a fixed number.
Right.
So you
So
can relate things.
if we look at the parameters in here, some of them are just numbers, right? The
Right.
difference is if I draw a circle in this sketch and I type OD,
Mm-hmm.
I get that listed. That's that's a dimension that's been converted to a user parameter.
Oh,
It's a named thing.
you're fixing it in relation to the rest of the.
I'm giving it a
doc.
name that
You're
can
giving
be
it a name.
used elsewhere. So like
Okay.
Jeff was saying, it's a variable if you think of
Okay.
mathematical terms,
So
or a constant, or a constant.
OD becomes an essentially numberless dimension that you can then.
Correct.
Yeah.
But
Okay.
You change
Larry,
that now.
pull up the parameter table again
Yeah.
Yeah.
and point out the ones with formulas, like the clamp
So-
ID is a formula.
Yeah.
That's
Right.
the big advantage of the parameter.
So once I
Right.
have those names, instead of them being model parameters, which are things like extrude 4, which what is that, right?
Right.
It has, or even worse, D33, right? What does that mean? I can now reference that as other things. So I use the fit tolerance a lot for that. The fit tolerance in this design, and that's one where I might use a parameter even for a one-off design, because depending on the printer I'm working with, I may want to change that. And tolerance is probably the wrong word. It's what sticks in my head, but that's the fit, right?
Okay.
Do you want
The clearance.
yes, the clearance. So we set it to 0.25. Well, what if you're working with a resin printer? That's gonna be a lot smaller, right?
Right.
What if, you know, it,
Or if
and-
you're working with a very large model.
or you've got a 0.6 millimeter nozzle instead of a 0.4, or you've got a 0.2 instead of a 0.4. So that fit tolerance can change. And that's one that for specific to 3D printing, I would probably put in anything I'm 3D printing. Instead
The
of,
point is, like your next parameter includes that fit tolerance. So when you
Right.
change one thing, it cascades through the model and
Correct.
updates everything else because you have those relationships built in the expression as a
And-
formula.
instead of
But
manually drawing that gap.
But if you didn't, if I didn't list, you've got an internal diameter and an external diameter, and they've been defined with dimensions in your drawing, but you didn't mention that the outside diameter is 1.25 times the inside diameter, but it is, numerically it is. You don't have to define the formula for the parameter to be recorded as
Only
1.25 times the internal
No,
diameter.
that's not right. That depends on your constraints.
Well, if it's appropriately constrained, the formula, do you have to write it as a formula, or does it not?
So let's say, what's this dimension?
The formula is just the relationship between the parts of the formula, and that's already baked into the fact that this is a parameter.
Sort of. So if I draw a circle here, that's 25,
Mm-hmm.
and this one's 50.
Mm-hmm.
So this dimension is twice this dimension.
Okay.
If I then constrain these two,
Mm-hmm.
not by their dimensions, why did it do that?
Because they have the same origin, so they're already concentric,
Right.
fully constrained concentric. That's what that double circle at the inside means?
Yes.
Okay.
So let me think of another way to do this.
Well, my point is that if you change the inside one to 50, the outside one would change to 100 because you've already constrained the drawing. It can't be anything else, right?
I just changed it, and it didn't change the other one because there's no constraint between the two. Now I could, without doing a named parameter, I could
Change that to a
say
formula.
that's this, and I just click on this dimension divided by 2, and that
Okay.
does the math, and it's a function. Now, if I
Now.
change this to 60,
Ah, okay.
the other one will change.
What would
So-
happen if you wanted the wall thickness to remain the same, Larry? How would you do that?
You would dimension the difference between those two.
Okay.
Yeah. Take off the ID and just dimension the thickness. That's why it's over constrained. Clear that,
Right, yeah.
clear that dimension and change that to a fixed dimension.
Once
Yeah.
you've placed a driven one, you have to delete the dimension and redo it. So anytime you see a driven dimension warning, removing the constraint won't remove the driven dimension. You have to delete the driven dimension and replace it.
Oh,
So now if I change, and this is why I'm saying right now, this one is half of this one because that's how we originally drew it. Now I've changed that to a thickness of 15. If I change this to 100, that's still 15.
okay.
I mean, if you're working and in your shop and you have one printer, I, you know, I wouldn't put a parameter in for that clearance. But if I'm going to publish a Fusion file, then I'm going to put it in there so other people can change it.
But
Okay.
your build tolerance that you have in your formulas,
Mm-hmm.
that's a perfect example of why you would parameterize it.
Oh, exactly. Exactly. And that's
Different materials or different processes.
correct. And that's why I'm saying in my own shop, I may not put them in there if I'm never going to share a part.
So,
But the
so when
minute
you,
I want to publish it, I want to put those in there.
so when you say when you parameterize a dimension, you are saying you are expressing that particular dimension in terms of other constrained parts of the diagram.
Right. And I actually did that ahead of time. I took your sketch and I figured out what I was going to call all those dimensions. I gave all those dimensions names. And then I
Name
put your numbers into
formula
the
to
table.
describe them.
And then when I dimensioned them when I was sketching, I would use the name instead of the dimension.
Okay, all right. That's really quite subtle, actually. It seems to me.
But that's where production, that's the stuff that I learned, from
Is this what screwed me up on the fact that my different elements of that 3D that cross-polarizing viewer were not properly parameterized? Is that why I could?
Probably not, but you could have saved some time
Yeah,
if you had, thought ahead and set, okay, my layer thicknesses are going to be or my, each stack is going to be a certain height, and just set it once and then just type it in later.
yeah.
But I don't know as it screwed you up. I think probably quite often when you have multiple components, what messes you up is either you've got linked components that you don't want linked, or you've got sketches that drive your component that don't live in the component.
Yeah, I was been very conscious of that.
Yeah, that's why the advice is when you start a fusion drawing, create a component before you do anything else.
If you have a
Because
part,
that one's tough to
if you
fix.
have a repeating part, a part of an assembly that's made up of three components,
Mm-hmm.
and there are four of these assemblies in your device, do you create the as a unit the three component assembly first, or do you create the components as groups and then merge them together? Do you go for the functional unit of three components as the thing you're going to copy? Because that makes
So
more sense. That's the way I'd build it by hand. No, it's not. I build all the same components and then I'd assemble them into
right.
groups. So how do you do it in Fusion?
I'm not sure there's a definitive answer on that. It kind of depends.
Okay.
If you were working with a group of people, you would want to build the components first. But when you're working by yourself, especially with the free version, I would start with the drawing and create components in the drawing.
There seems to be a significant difference between the free version and the purchased version when it comes to the important stuff like this?
Well, I mean, it's not bad managing the 10 editable. But when you're doing a multiple, I mean, so from my formal training and CAD management background, I would want all those things in separate files, right? Every component would be a separate file that I could live by itself, be documented and available to other designers.
Okay.
You're working by yourself and you have a 10 editable document limit. It really makes sense to have the components live inside that base drawing. When you work in Fusion's big brother Inventor, they have parts and assemblies. There's actually two different file types. The part is a component. The assembly drawing does not have any parts that you design in it, but you insert parts into it.
Okay.
I didn't even realize Inventor was still out
Oh
there.
yeah. Oh yeah. Um,
It sounds intriguing.
two of the firms that we support right now are Inventor shops, and they do have a little bit of Fusion for when they're looking at it for their CAM processing step. So the Inventor workflow is they have a whole different piece of software that takes that 3D design, that part, and puts it into like a slicer. They have like a slicer, right? That sets it up for the milling machine. One of the things that makes Fusion is that there's a milling program in there. So you can set up your milling right in Fusion. So a lot of them are looking at taking their Inventor parts and bringing them into Fusion to do the machining process.
I thought most industry was using SolidWorks.
A ton of them are, but so the shops that started as AutoCAD shops tended to go to Inventor because they had an established relationship with an Autodesk vendor. Inventor's an Autodesk product.
So on this, Larry,
Mhm.
there are three problems. One is I built the joint and I was able to show it working, and then I couldn't anymore. And it's because the third component, which is the ring on the inside, is supposed to move out with the arm and supposed to revolve around the central axis. But it can only do, as far as I can tell, one of those. It can't. Maybe I'm just rotating it in respect to the wrong component. The ring, component number 3, called the cassette. The cassette is supposed to stay with the draw, component number 2. So when the draw swings out, the cassette is
supposed to go with it.
Yeah.
And what's up here?
Okay. The chassis is the bit that doesn't move. Part number 1, which isn't actually shown there.
Would it help to color code them?
Yeah, they were color coded when I sent it over, and yeah. And for some reason, the first part, the chassis, isn't showing up. There it is. So the chassis holds the draw, and the draw holds the cassette.
So I think this orange piece is supposed to kind of be stuck to the inside of this.
Yeah, it is. So that when it turns freely, it's independent. But when you open the drawer, the drawer swivels out to the right. The cassette's supposed to come with it.
Okay.
So I made hell, how did you do that? That was exactly what I've been trying to do for 3 days.
Oops.
That's the best part of training, is getting that response.
He's a wizard.
I
Uh,
didn't see your hands move. How did you do that?
all right. And it was probably wrong, just so you know. I just wanted to see what it was going to do. So I went
Okay.
into assemble,
Right?
joint. I picked this circle
Uh-huh.
and this circle.
And does that automatically know it's a revolute joint around the center of the circle, or
No, right now it's rigid,
okay?
but you could make it revolute, and you're not going to really see anything because that orange thing doesn't have any features
Correct, correct. But that,
that show that.
can you make the first joint work properly now? Um, it's revolute 1.
Whoa, what
It's
happened here?
constrained to 90 degrees. I couldn't ever get it to work again once I. Well, it's 85 degrees I made it to, but that. At one point I was able to just grab it with my pointer and open it and close it.
Oh, well, so your minimum and maximum are 85 degrees.
Well, that
Minus
changed.
85 degrees.
That was 0. There it is. And then when I did a motion study, it would open up, but it would leave the ring behind. So that bit never moves.
I think because it's not a component, that's a problem.
Well, it was the first component I made.
So let's delete that.
Somehow it became a body. So the problem that this all started with was how to copy this with all of its joints intact.
Okay, the other problem is you have the cassette grounded.
Oh, I do.
Yeah.
How did I do that?
I don't know, but the little anchor,
Yeah.
there was a little anchor on the cassette.
The only
So
thing
now
that's grounded.
Let's recreate this joint. Joint here and here.
If something's grounded, it cannot move in a joint.
It's not going to move. It's frozen.
Okay. So how do you connect it to how do you connect the cassette to the drawer without grounding it?
Hang on just a second here.
Yep, yep.
I just want
I'll give it some.
I just want to have something so we can see.
Right, right. I'm,
Okay. All right. So now we have the two joints. Oh, select joints. Man, it's been a while since I've been in here. Did I Revolut? Oh, minus 85.
yep.
There we go.
You changed the other number to minus 85.
Yeah, I don't understand why it does that.
Unlock it.
It won't leave them where I put them. The first time I did it, it would swing out to 95 and then 85 and go back in.
Oh, there's two components selected. That's why. All right. What the heck?
Ah, there's my window that I had made earlier on that had disappeared. That's so you can turn the cassette.
Okay, we're gonna get rid of these.
Just to put it in your mind, there's a part of the chassis that I meant to have as part of the drawer. It's the same part. Can you move part of one sketch into an part of one component into another component and move it basically so it's connected to the second instead of,
Sketches, no.
no.
I
So
mean, you
you
can
need,
project from one sketch to another, from one
then just redraw it.
component. Yeah, but then
Okay.
they're when you project, they're linked, so you'd have to unlink it.
That's why I keep having to start redrawing this. I meant that for that bottom shelf to go with the drawer, not to stay with the chassis. The chassis
Right.
got plenty of rigidity, but the drawer doesn't. Yep, this is the problem I ran into, was this. Well, I don't want to take up. Oh, hang on, you've got something going on there. That's actually the chassis that's doing the rotating.
Is it?
Yeah, that's the whole chassis is going around. And the two bits that are supposed to rotate are staying still.
Well, I would have to look into the, I'll play with it a
Yeah.
little bit.
It's very close to what I wanted as far as the function of it. And if I put a metal pin through that hole, it would probably work as is if I just printed the parts.
Yeah.
And there is, when do you do that? When do you just say, the hell with getting this drawing right and just print the parts and put them together? Never.
No, I mean, yeah, just like everything, the real mastery comes in knowing when to stop, right? I mean, that's true with photo editing, right?
True.
It's true. It's true with this. It's true with, sand and wood. If you don't know
Yeah,
when to stop, you won't have any wood left.
yeah.
The only thing that concerns me is that looks pretty dang skinny.
It does,
Thin
but
wall there?
Huh?
That thin wall?
Yeah.
That's very,
but it's not weight bearing. It's just going to, the drawer swivels out to give you access to drop in a cassette. It's not going to.
right. But as you over travel the opening situation,
Yeah.
you're going to be stressing that
Yeah,
area.
you're
That's going
right.
to be highly subject to fracture.
Well, maybe I'll put a
Well,
bushing in there and a 2 mm pin, and well, then the bushing will break through. Well, I can
right.
make it off center, can't I? And it'll still open.
Yeah. Yeah. It looks too, so that's something that in the 3D printing design world that it took me a long time to get used to. It's very easy when you're in Fusion to lose sense of your scale that you're working on. You can look at this and go, oh, there's plenty there. And then you measure it and it's like, oh, that's 0.2 of a millimeter.
Yeah,
You know,
yeah.
I don't know what it is, but you know what I'm saying? It's just
It
easy
actually is
to,
about 0.2 of a millimeter, because originally it was all the way through that thing. And yeah, so I made it as small as I thought I could get away with, because that's only 2.5 millimeters. 3.5 millimeters across.
Yeah, that's way too thin.
Yeah.
10
Okay.
thousandths? Oh no, that's the other dimension. What's the wall thickness there? The minimum wall thickness?
0.25 millimeters. That's
10 thousandths.
that's thinner than you can print.
Yeah. So I'll have to move it.
Yeah.
Okay.
But that's a mistake I still occasionally make. It's really easy to lose track of, you're looking at that thing and that doesn't look like 0.2 of a
Well,
millimeter.
it always looked iffy to me, and I figured you were going to say something about it because it does look so thin. But honestly, I don't have enough spatial orientation to tell how far I could move that hole away from the center of that circle and still have it function. See, when I move the hole towards the outside, what's going to happen is that is no longer going to turn like a circle. It's going to be a cam, and it's going to raise up one edge of that thing when it's standing on its side.
No, it'll work.
Increase the wall thickness around the pinhole and just cut out the sliding member.
No, but
There's
it
like
should
a little
work.
divot there.
It should work with an off-centered hole.
Well, as it's off-centered, the perimeter, the circumference, is going to change in relation to its distance from the center of the actual diagram.
Yeah, but it's going to be opening.
Right, but it'll raise up one side of the base of the device. If it's turning around the center, then when it turns, it'll be flat. But if I
you're
move
horizontal?
to the outside, it's going to be like a cam. If that hole moves away from the center of the whole device, then
Just hog out a little material from the pink ring and add a little bit more wall stock.
Whoops.
Oh, yeah, there's a lot of things I can do to fix it. I can even just put a flat section of print between the two rings. I just liked it because it looked like an Art Deco toaster. Oh, you're moving the whole ring out. That's different. That makes more sense.
Yeah. Just put a hole here and it'll.
Yeah, and then redraw the circle. Yeah.
But that won't work, will it?
No.
Yeah, if you put the center of rotation further out, as Alan says, you're going to get a camera effect, and the ring is going to foul the outside of the holder.
'Cause
Surely,
it's not concentric.
yeah.
It'll catch on the corner.
Catch on the corner or
You're
what?
right, Graham.
Yeah. Well, I can
Catch on the corner of what?
the chassis. The chassis isn't going to move at that edge. I could carve a piece of that out to give it relief. The
Or you
chassis,
can
yellow top.
move the pivot point farther down in this orientation, and that'll give you the clearance to get around when you're closing.
When you say down,
If you move the pivot pin a little bit to the left and a little bit down, it'll
Okay.
accomplish both things.
okay, so a bit there and a bit down. Okay. I'll experiment with it now as I know how to make the joint. Yes, okay.
But I'm not really thinking this out. I'm just putting that there to
Right,
get a
but
place to.
As it's rotating, it's going to clip that corner.
Oh, here.
Yeah, right.
No, the corner, if you draw a line directly between the two pinholes that you have drawn, go all the way
but
to the inside. Follow that
Right.
line.
Yeah.
It'll clip right there. That's where it's going to catch. You could radius that out, or you could just move the new pivot hole
Right.
farther to down it over to the left a little bit to clear that when closing.
Will 360 show me the motion and show me where it is potentially being blocked, or will it just turn right through it?
It'll turn right through it. You can turn that on, but you
Okay.
should be able to see it,
Okay.
which is usually enough.
You see the what I'm trying to get at here
Yeah,
with the
yeah.
design is so that it can be used in this lying on its back like this, or it could be used standing up on its edge with those two cylinders as its supports. And the reason I liked it was the support on the side with the joint can be used as a joint without changing the anatomy of the support. You can open that drawer and it still remains a cylinder of the same shape, so you can support the device on it. It just because there are 4 of these and they're sandwiched with bits that don't move from the chassis. So you've got 4 of these joints inside a cylinder of chassis, so that they can all turn at once or one at a time to load the cassettes without taking away the supports that they're standing on. I'm just going to have to show you this when I've got it finished, because it's pretty clear in my head that it'll work like that until it busts through that thin wall.
Yeah, I think maybe the best thing to do would be to just increase
The wall right there.
the wall thickness.
That I can
Yeah.
do.
The other question I'd have is if you have all the drawers pulled out fully open, what does
Yep.
that do to your center of gravity? Is that still going to be sitting stable?
Not really, but I'm thinking of drilling out the cylinder on the right and putting a metal bar in there to just give it some weight at its base.
That would address it. Yep.
Kind of to counterbalance the hinge pin, which is going to be another piece of metal holding it.
Because if you open all those 4 drawers?
Yeah, there'd only be probably at any given time one of them open at a time. You'd open them to place a specimen or to place change a piece of filter.
Well, because
Not
you're also
any
adding
mass
weights
to them.
inside those drawers. That's adding a lot.
Very little though, very little weight. It's going to be the cassette I haven't finished yet is actually a sandwich of two pieces that slot together over little pins and they click into place. I've made them already and they work great, but they don't add much weight to it.
Yeah, it's going to PLA, right?
Yeah. PLA plus.
But you're adding glass on top of that, aren't
No,
you?
no glass in it. Well,
Oh,
correction.
okay, I misunderstood.
A glass, there will be a glass slide, a microscope slide that will span the second of the drawers. That'll be your specimen piece. Gosh, I've got all this drawn out in the other drawings that that I redid because of this hinge thing. So
It's just very hard whenever you're doing any design to figure out all the places it can possibly fail.
sure, no, I definitely.
Figuring out failure analysis is probably the most difficult thing of design, in my opinion.
Yeah, it is for sure.
Yeah, I'm liking this. You've kept it concentric and you've just shifted it in relation to the. That should work perfectly.
Then just
Then
cut
cut
this.
clearance there.
Yeah.
And the other
Okay.
thing I want to do is move the floor of the chassis onto the floor of the drawer, so there's something to support the cassette when I open it. But that's trivial.
I'm still not happy, chaps. I'm so sorry.
No, it's fine.
I think that as you open it, because of the eccentricity, that the rotating ring will foul the outside of the whatever Alan called it, the drawer. If you have a pivot outside, the further away you get from that ring, the more eccentric the movement will be, and it will.
In relation to the ring.
Yes, it will foul the outside on the opposite edge. So not.
But I can cut relief for that.
You
But-
could
okay,
radius
well-
that out to give you the clearance. It just won't be as pretty looking.
Yeah, it's still got to rotate, so just be careful. The further you go out, the worse, the more clearance you're going to need, and it will be quite large, that clearance.
Yeah,
So-
and it'll look ugly too.
I think I
could
would
go back
I
to
would
my-
make your cut, move it. Offset that cut.
Yeah, because now it's going to swing out as it.
Yeah.
Yeah.
Alan, I know, and everyone's going to hate me for saying this, but this is a cardboard and a pin job. To
Yes.
evaluate what you want.
Already
I mean,
done-
I know it's a
already
long way,
done, right?
might be a long way of thinking about it in terms of the design on Fusion, but it's a sort of.
That's a perfect.
No,
Yeah.
I already did that on this initial drawing where the only thing it didn't take into account was the thinness of that wall. I had already cardboarded this out, cut it, pinned it, and checked all the clearances, and it worked great. Except I didn't take into account how thin
I mean,
that wall
the
was going to kill me.
the traditional 3D printing approach to this is just to make that whole wall of the cassette thicker, expand it to the outside, double
Chuck
it even.
I was just trying to keep the proportions so that it looked like an old-timey alarm clock, but I can there's no particular reason for it. I just got attached to it. All right.
Perfectly
You're
understandable.
sounding like a real designer now.
Yeah.
Aesthetics over function.
Yeah, right. Right. Who cares if it doesn't work?
You'd think he was from New York.
Not Middle Earth.
You want a perfect study in that? It's your mouse.
Which one? My Mac mouse?
Yes.
Yeah, I threw that thing away. I don't know where it is. That's useless.
I think Mickey Mouse might be more appropriate.
You can't use it when the cord's plugged in.
It's-
Well, Guys, I'm going to have to go. We've just
And
been
me.
listening for 4.5 hours. So this was brilliant, Larry. I'm glad you let me come over here and look at this, because I've learned a lot about what not to do here. This can be so cool when it's finished. You're going to love it, and it's going to work.
You'll
I
probably
hope
make
you have higher
millions
suc-
selling it on the open market.
I hope you have better success with finishing projects than I do.
Oh, I haven't. I certainly haven't so far. I still don't know how you did that magic thing of moving the cassette over. I'll have to practice that.
I'll fix it and send it.
Well, you offered last time, and I said, no, I'll do it. And here we are a month later, and I still haven't got it working. So maybe I'll take you up on that.
So
All
you
right,
got
guys.
any ideas on homework?
Oh, yeah, make one of these and make it work. Submit them to me, though, and I'll break them.
Or
No,
a
what do you
topic?
think? What do you think for topic? And it's something with a joint, something with an as-built joint that you can. It doesn't matter what it is, just to make the joint and show how it works.
Just an idea, Larry. How about you creating something as a test and us fixing it?
No dear.
Well, I mean, something simple for me. But
Right. No, I understand what you're saying.
That's a good idea.
I love it, except for the fact that I have to do something. But
Yeah,
That
the
wasn't in the
assignment is Larry,
contract.
you do the work.
That wasn't in the contract.
yeah,
sorry, Larry.
no, it's a great idea.
Super idea. Just
He
put it
started-
over on Discord.
Or give you an assignment,
Yeah.
like a model this thing. Here's the parameters, or model this thing to fit this thing. Something that you can like a lab exercise in a CAD class. All right. Keep an eye on Discord, and I'll throw something in there.
Okay. Very good. Oh, guys, that was awesome. Thank you so much to everybody for participating and contributing. That's been very, very helpful to me, and hopefully to everybody else. If anybody has any ideas on this crazy build that occur to you, let me know.
Oh, it's rolling around in the back of my head now, and I won't be able to think about anything.
Trust me, that's not going to get any better. It's been rolling around in my head for 3 months. All right, guys.
This whole exercise has got me off the tractor for a while.
Yeah, me too.
Thank you, Larry. Thank you, Alan. Thank you,
Yep.
everybody. I've got to head off.
Okay.
See you
take care,
next time.
everybody.
Thank you very much.
See
Bye-bye.
you on Tuesday, Thursday, Saturday, something like that.
Lovely.
All right. Take care.
Bye.
Bye.